All right, so let me update the answers here. So if my network was working, I could show you what I see. But I'll just have to tell you. So answer A got 9% of the answers. Answer B got 82%. Answer C got 4%. Answer D got 5%. So this is a great example where, I lecture along, and I think everyone knows what's happening, and whammo, reality hits me, because the right answer got the least responses. Why doesn't it compile? Yeah? What's that? So ponder this for a minute. Why doesn't it compile? Let's look at util on the previous slide. What does util return? What type does it return? It returns a comparable. And over here, that comparable is put into a string. And the Java compiler will say, well, wait a minute. How do I know that particular comparable is a string? It could be a country or a watermelon. It has no idea what type it is. A comparable is a very general type. It's anything that chooses to implement the comparable interface. So what's the remedy? You have to cast. So in this situation, you have something that you know that you don't quite know to be what you know, but the program just doesn't know. You know you fed it strings. So whatever the smallest one, it had to be one of the strings. But the compiler has no particular way of knowing that. It cannot trace back and forth across a function call like that, so you have to use the cast. Okay, so that gives you an idea of what these clicker questions are like. So normally when I ask a question, I do try to ask a question that has at least a little bit of a twist to it. So go and try to find it. But I'll trick you once in a while and put a very straightforward one without, just to keep your brain occupied. So yeah, try to look for the catch in this. So another one. So go ahead and answer this one real quick. So I'm asking you, what's the point of using comparable? Why are we going through the effort of using comparable instead of just doing the obvious thing and just writing a method that takes strings or countries, and then not having to worry about casting? So let's have 2 minutes for this one. That's bigger. All right, so this time the majority got the right answer. So let's just go through these various options here. What's wrong with util smallest of string array? Well, that's not so great because then it only works with strings. So the whole reason to use these interface types is to write code that works with more general things. So what about measurable? Well, measurable is kind of good. I mean, that's what we've done in the book. But as you've seen on the beginning slide, some things are comparable but not measurable. So in real life, comparable is the better choice. What about object? Now, object sounds even more general than comparable, right? Everything is an object. So if I could write a method that gives me the smallest of all objects, that would be super cool. Then I could just put in anything, whether it's comparable or not. But if you think about it, it can't work. If you can't compare the things, there's no way of finding out what's the smallest. So that's where the comparable comes in. It has just enough information to determine the answer, namely to compare two things, but it is it's not so general that you don't know anything about it. So just by sheer elimination, D is right, and so it has this goodness that you can now use this method with anything. Excellent. So moving on to the last twist, this is section 9.4, I think. So country implements comparable. It's wonderful. I can take an array of countries. I can find out what's the smallest. I can do even more. I can pass it to arrays.sort. So in the standard library, there's this nifty arrays.sort method. If you ever need to sort something, you just pass it on to arrays.sort. As long as the objects are comparable, you'll get it sorted. How do you get them sorted? You get them sorted by area, of course, because that's how comparable works. What if you want to have them sorted by name? Well, of course, you could rewrite the class. Oops, you could rewrite the class so that it now implements comparable in a different way. And in a homework, that will work fine. But in an actual real-life project, you can't replace classes all the time. They're there in real working code, and you can't have one version of the class here and another version of the class here. So the trouble is that comparable is good, but it's not really good enough. Because if you have more than one way of wanting to compare something, then it doesn't give you the flexibility that you want. So they thought of that, of course, and they said, well, in that case, you get an escape hatch, the comparator interface. So the comparator interface is kind of funny, and it has a single method, compare, of course, and it takes two objects, the first and the second, but it's no longer attached to the class itself. So the comparator method in country was a method of country. If I now want to compare countries in a different way, I have to make a new class with this method. Here is one. So here you have this class called country comparator by name. It implements comparator. And it takes two objects, casts them to country, just like it must because it's been handed objects. And then it compares them by name by calling the name of the first one. And then it calls the string comparator. Get name is a string. The string comparator, and compares it against the name of the second one over here. So it's pretty simple. What's just different here is that you have to make a new class, a brand new class, just for the purpose of making a comparator. That class has a single method. So it's maybe not quite as natural as adding the class, as adding the method to the existing class. You just have to create this new class that's just there to make a comparator. All right, and now comes the first question where I'm asking you to reveal your name. You don't have to do anything. Your name shall be revealed. I don't yet know how that's going to look, but because the first time I'm doing it myself. But when you answer this question, I will know who answered it. So with that caveat, ladies and gentlemen, you have 3 minutes. Okay, I only have 19 votes. Oh, you didn't see the options anymore. I'm so sorry. Here. All right, so this is pretty evenly divided here. Like Ron Paul is catching up here on the bottom. All right. So I'm looking at the first one. So let's decipher this. So arrays is the name of the class. Who wrote the arrays class? Somebody at Sun Microsystems at the time. It's a standard class. It's part of the Java library. So here's the sort method, and it takes an array of some type T, and it takes a comparator. Never mind the question mark super. It takes a comparator. So, so the first one here, look at it again. So we have the name arrays. This first one actually has 30% of the votes. It has arrays, and then it has dot country comparator by name. What is the thing after the dot? It's the name of a static method. That's how you call a static method. Name of the class, dot, name of the method. What's the likelihood that someone at Sun Microsystems 10 years ago called a method in a programming language that's made available to 50 million people or more, that they called that method country comparator by name? That just sounds kind of unlikely. Right? They could not anticipate the admittedly wonderful textbook that you are using. So that can't be it. So let's look at the second one here. So we have arrays.sort. Now the first parameter is an array of countries, let's assume. The second one, what is the second one? It's the name of a class. Can you pass a name of a class to a function, to a method? 21% of the votes say you can. So can you? No. So when you have the name of a class, you can use it to make a variable of that class. You could say country comparator by name, Fred, and make a variable of that class. Or you can use it to make an object of that class. Country comparator by name Fred equals new country comparator by name, parentheses. And that's really the only context in which you can use the name of a class in Java. Well, I guess the third one is you could extend that class. Class Fred extends country comparator by name. Those are the things that you can do. But you can't just pass it to a function. So that rules out option B. Let's look at option C. Well, that actually looks good. Countries is an array. And here we're making an object. New country comparator by name. That's an object of this comparator class that magically can compare two countries by name. And D is, of course, bogus because if you look at the country comparator by name, it does not take an array as constructor parameter. And you know that because when you look at this class here, it doesn't even have a constructor. Can you have a class without a constructor? Yes or no? Yes, you can. What happens when you construct a class without a constructor? A class that has no constructor, that cannot afford a constructor, is provided one by the state. And that constructor does absolutely nothing. Which is probably what happens in that other situation where something is provided to you by the state. So, if you can't afford it. So, nothing happens, but nothing has to happen because this country comparator by name class here, it doesn't even have any instance fields. It's a very weird class. It's just there to carry that one method. But sometimes that's a convenient thing to do, and so you've seen it here for the first time. You're going to be seeing that other times, particularly when you do user interface programming in the next semester. All right, that brings me to the end of this lecture. I'm just not going to do this part because we're running out of time. So I want to move on to the lab. Come on, lab. I know you're there. Okay, I don't know you're there. All right, so now to do the lab, we're going to have 10 minutes of more fun than you ever thought possible because you're going to have to find your buddy. So I've tried to keep them reasonably alphabetical, and I may tweak them a little bit later. So what I suggest you do is that you kind of move yourself into an alphabetical corner where, like, the A, B, C, D, E, F's are here, G, H, I, J, K, L are here, M, N, O, P, Q, R are here, and the rest is over here. And you try to sort yourself out with your buddy. So look up on the laptop who your buddy assignment is. And I realize it's going to be a few minutes of chaos today while we do this. If you were not listed on here, if you do not have a buddy on here, then come up to the front and I'll deal with it. Obviously, my suggestion is that starting on next week, that you seat yourself wherever it is that you'll be sitting for the lab today so we don't have to go through the circus again. Thank you.